in order to get to a better understanding of what Git is, what it does, and how to use it. Now, I understand from Friday that some of the concepts that we covered were unfamiliar to many of you and quite abstract and maybe a bit difficult to get the grasp of if it's the first time you've seen them. So I'd like to just ask you, since you sat in on the class on Friday, to tell me what you found challenging about what we did on Friday. Because it's definitely challenging material. I realize that. And in a sense, I'm glad that I get to challenge you, but I also don't just want you to drop you off at the deep end and tell you to sink or swim. So if you could just jot down a few words and sentences about what you found challenging about what we did on Friday. Mainly we covered two concepts. We covered hashes and hash functions, and we covered the concept of a graph, more specifically a directed graph, even more specifically a directed acyclic graph. This is of course a very abstract notion. It's a mathematical or computer science construct that is very useful to know about. Once you have that model in your toolkit, it's easy to, you'll see where it can be used in many different circumstances. However, I'd really appreciate it if either you among the students could tell me about what you found challenging last class, if it's possible to put it down on paper. Otherwise, maybe Michelle or Nicholas could, by show of hands, try and figure out what might have been difficult about last class. So, anyone? If we start off with the concept of a hash function, did that topic make sense to you? Yes or no? Simple yes or no would do. And it's fine to say no. So for some reason I can't see any activity in the chat. Are we still live? Okay, so one difficult area was using MD5 and SHA-1 sum to get a hash. Okay, so that's the practical aspect of actually taking a file and finding its hash once you have a program on your computer to do so. Okay, that's definitely something we can look at again. Now, what about the concept of a hash itself? The idea of taking a file and reducing it to a number or a string. Singh is saying that in his understanding, MD5, SHA-1, SHA-256 are pre-installed on Linux, but you found that MD5 is not a command. Aha. Okay, so the thing is, they come pre-installed. Several of these programs come pre-installed with many distributions of Linux. As we talked about in the Linux course, for those of you who attended that course, it really varies a lot across the distributions, what kind of programs you find pre-installed. The only sort of answer to what is always installed is programs that are included in the Linux standard base or POSIX. These are not among the standard programs that you usually that you're guaranteed to find on a Linux system. But you can usually install them. Like any distribution will have them in their package manager. So if you didn't have them, you'd have to install them. And I'll bring up my Ubuntu and let's see if we can find it on Ubuntu. What distribution did you use? What version of Linux did you use? And while I bring up my Ubuntu disk image, again, the concept of a hash. Does the idea make sense? You basically take a file and you go through every byte, every letter, every single piece of that file and combine them in some way into a small number or string. And that string is like a fingerprint of that file. So again, maybe if Nicholas or Michelle or anyone who's among the instructors could gauge the room and find out where we're at, I would be very appreciative if I could get some feedback. Now, while I'm getting feedback, let me try and bring up Ubuntu. Here. Let me see if I still remember my password. All right. Okay, let me see now. Can you see the entire screen? I hope you can. So let's see now. Michelle is saying half the recruits are using Ubuntu 18.04 and the others are using Windows subsystem for Linux. That should be perfectly fine. What I'm going to tell you is going to apply to both of those. No, I don't know what comes pre-installed with Ubuntu on Windows or the Windows subsystem. But we're now going to do a quick review of how you get to the hash from a file. And I'm going to do that on Ubuntu instead of on my own Arch distribution because there might be a difference and I guess it's better if we do this on the same kind of system. So I'm going to do this in Ubuntu. And as always, we're going to do things in the terminal. So let's bring up a terminal window. Can you see what I'm typing here? And actually now things are a bit complicated on my end because I can't see both the chat and Ubuntu at the same time. So let me try and switch back and forth here. Is it a bit too tiny for you? Some people are saying no. Okay. Let me try and increase the size of first the window and then the text. Window and... Oh, is it not going through? Okay. Let's try and do it this way then. Text, it should be here. Columns, font. Okay, let's set the font size to huge, 30. Okay, is this visible to you? That looks much better. Okay, very good. Okay, Okay, let me try and see if I can bring the chat over so it's actually possible for me to both work in Ubuntu and follow the chat. All right. So first thing I'm going to do now is to just create a file, because we need a file to hash, and right now I don't think I have one. So I'm just going to open a text editor and type something. Roses are red. Okay, and I'm saving that as poem.txt. Now we have a file. Let me just list the files here. ls. And there's poem.txt. Now we have a file. Okay. This is now the file that I am going to hash. I'm going to take this file and reduce it to a fingerprint. There are many ways of doing that. We talked about that. There are many algorithms, many different functions. These concepts basically mean the same thing in this context that you can use. And we looked at MD5, and let's check and see if we have MD5 installed. So MD5 was not found. Okay, so I'm guessing that on Ubuntu, that's a problem that a lot of you ran into, correct? Now let's try and find out if we can install it. And in fact, I don't use Ubuntu that much, so I'm not sure exactly what the package is called. So I'm going to do what I would do in under any ordinary circumstance. I would Google it. MD5 Ubuntu package. How to install MD5 to Ubuntu. Superuser.com. Ubuntu has included MD5 Sum in their distro. That's what it might be called on Ubuntu. Let us see if we have MD5 Sum. MD5 Sum. And something's running. So yes, it exists. I'm going to close it down. Control C. In the Linux terminal, if a program is running and it's hogging the terminal and you need to close it down, press Control C and it exits. So we actually do have it. It's just called MD5 Sum. If I now run MD5 Sum poem.txt, there we go. Now we actually have a hash. So the first string of digits and letters that you can see here, that's the actual hash. What it prints next is the file name that it's the hash of. So what MD5 Sum did here was to take poem.txt and reduce it. Well, in this case, not really reduce it, since the hash might be longer than the file itself. But it produced this hash that was, I don't know exactly how many characters long. Of course, it would take any file at all and give us a hash of this exact size and length. And that could be used, for example, to identify files. Now, are you able to reproduce this on your own local computers? Could you try and do this? Bring up a terminal, create a small text file, and hash it. So an easy way of doing this without using any text editors would be the following commands, the following instructions. If you follow the Linux course, you would know that you can use echo to print any piece of text and even redirect it into a file. So we could take the string hello Umuzi, for example, and we could redirect it in this way to a file name named, for example, Umuzi.txt. Hopefully this should make sense to you, and this will definitely work on all distributions of Linux. If you press enter now, it will have created a text file which contains the string hello Umuzi. Can you do that? Oops. Of course, I have one version of Linux running inside another version of Linux. So when I press buttons, sometimes the wrong version of Linux responds. Right. You still with me, guys? You still in the chat? You still there? Okay. And are you able to do this? Again, we're creating a file, and try and type exactly what I did. Put hello Umuzi into a file, capital H, capital U, one space between the two words, and put it into a file called, for example, Umuzi.txt. And say done in the chat when you're done. Okay, some of you have started to tell me that they are done. Michelle, Nicholas, how are people getting on? If you need to check that the file has been created, list the files in the current directory by typing ls, and it should tell you, it gives you a list of all the files and directories, and among those files and directories you should find Umuzi.txt, which you just created. If you want to verify that the file contains what you want it to contain, you can use the cat command to actually print the content of the file. So you can run cat Umuzi.txt, and it should tell you hello Umuzi. So you're almost there. Okay, that's very good. Now I can see in the chat that some of you have done a lot by actually downloading the Ubuntu distro, ISO, etc. So that's good. We'll come back to that later on. If you've been able to complete some of the exercises, that's excellent. Now I realized the wording on the problem set was a bit confusing because I didn't actually intend for you to download the ISOs. The hashes are actually listed on the website. So I just wanted you to find the hashes and not to actually download the ISO and then compute them. But we'll come back to this later. Everyone seems to be done, all good. Excellent. Okay, what we're going to do now is going to be to hash that file and well, find its hash. And we'll start by using MD5 sum, which all of you should have. Remember, it's called MD5 sum. And you run that by typing MD5 sum and then the file name, Umuzi.txt. I want all of you to do that, and then I want you to tell me the actual hash in the chat. And I'm not going to do it because I want to check and see if all of us have the same hash. Now this would be fun because we've all typed up this file independently, yet the files should be identical and the hashes should reflect that. As long as you typed hello Umuzi the exact same way as I did, with a capital H and a capital U. So once you've ran MD5 sum Umuzi.txt, do you think you could put the hash into the chat? Just type it up for everyone to see. And I'm not going to run this until I see that you've started to do it, so we can see what hash we're all getting. Yeah? How's it going, guys? Are you finding any hashes? Or are you running into any problems? Okay, so some of you typed hello Umuzi in small letters. That's fine. Just print the hash. Let us see the hash. Are you able to copy paste it into the chat? Nicholas, Michelle. You still with me? Because the chat seems really quiet. Well, okay. Since none of you have produced a hash yet, I'm going to run this command now. And what I'm getting is F3, F8, 3, etc. So let me see if I can copy this into the chat. I haven't set the clipboard to be bidirectional, have I? Shared clipboard. Oh, I have. Copy. Okay, so everyone's done it, but it's not showing up on the chat. That's interesting. Can you confirm that you're getting a hash that starts with F3, F8? If you do, then type yes, exclamation mark, or something like that. And if not, then no. Sydney is saying that we've got the same one. Johan, exactly the same. Saying yes, excellent. And if you accidentally typed it up with small letters, let's see what you would get then. Hello, Umuzi. Then it seems like you should get 38E, 3A, etc. Yes, so this is great. We typed up different files. We got the same hash. Of course, because the content of the file was the same across all of you. Very good. Now we tried MD5. Let's try a different hashing algorithm. So I'm again just going to make sure that my file says hello Umuzi with capital H and capital U. If you haven't made any changes, you don't have to run this again. But I just changed my file, so I have to change it back. There. Now my file says what it ought to say. Hello Umuzi, capital H, capital U. Let's try SHA. And on Ubuntu, you should find that SHA-1 sum is installed. And do you know how you could check whether or not you have something starting with SHA as an executable? You can type SHA and press the tab key on your keyboard twice. And it'll bring up all the applications or all the executables in your path that start with SHA. It's called tab completion. When you're in the terminal, you can use it to finish file names really quickly. So say I want to type SHA-1 sum Umuzi.txt. What I can do is type SHA-1 sum um tab, and it'll complete the file name because it's the only file that starts with in this directory. It makes things faster. It's a very convenient thing to know about. And also, if you don't remember the full name of the command, tab complete it and see if you can find it. So if we now check the SHA sum, you should get something like 89326. Can you verify that? Yeah. Very good. What about the rest of you? Do you agree or do you disagree? You agree. Okay, very good. Now, let's then try to do exercise 1 of the problem set together. Because now we ought to know enough to do it. Except, actually, there's one more thing I want to show you. I told you that Git is using SHA-1. So what if we try to run git hash object Umuzi.txt? You get a hash But it looks different from the SHA-1 sum that we found, right? If we use git and git's hash object function, which is what git uses, you get something that starts with 00F2. Is that correct? Now, while you type that out, the reason for that is that git actually adds a little bit of information to the file before it hashes it. So not only does it hash the content of the file, like SHA-1 sum and MD5 do, it actually adds on a keyword and some metadata, some data about the file before it hashes it. And I think we should be able to reproduce that actually. And don't get too confused for what I'm typing out now. This is sort of experimental. I'm not sure if this is going to work, but we're going to type out the letters blob, a space, the size of the file, which is the number of characters in it, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, plus a new line, which always gets appended. That should be 12. Then a literal 0 byte, a byte which consists of exactly 8 0 bits, and that can be typed out as a \0 sequence in bash. If that doesn't make sense to you, don't worry about it. Just know that \0 actually produces a character, a 0 character. Then let's do hello, Umuzi, and a new line character. New line can be typed with \n. This is the / plus a character sequences that you see sometimes are called escape sequences. They're very common when you work with strings in C and on Linux. \n produces a new line character, a line feed character. \0 is 0 byte. Let's try and see what SHA-1 sum claims the hash of this is. 00F2C11, which is exactly what git hashed the file to. So git uses SHA-1, but it adds some data before it does the SHA hash. Does that make sense? So if the syntax there didn't make sense to you, I used the printf function, which is similar to echo in that it takes the next string and interprets it and sends it as standard input. Well, it prints it as standard output. Then I used a pipe, which takes standard output from the previous program as standard input to the next program. And SHA-1 sum actually accepts data on standard input as well. You can use it in this way as well as running it with a file name. And now you can see that it didn't get the file as an input, so it just prints a dash as the file name. Instead, it just got the data directly on standard in. But the data that it got on standard in hashed to 00F2, etc., which is what git is claiming the hash of that file to be. Okay, now we only have a few minutes left of the class, so I want to quickly run through the solution to the problem on the problem set. So let me see if I can find that for you. This should be the PDF. This is the exercise sheet that you were given, right? And the first exercise was We have 5 minutes. Okay. Really quickly. The first exercise was not actually to download a Ubuntu disk image. So I'm sorry that it started with the verb download in the very first sentence. It said, if you want to download an Ubuntu disk image, the distro makers provide hashes or checksums. So what I tried to get you to do was to go to this website, releases.ubuntu.com, and find the hashes and the checksums there. So let's quickly do that. I'm going to copy the URL and I'm going to bring up the browser if I can. This is the browser. Releases ubuntu.com. I hope you can see what I've got on my screen. Might be a bit tiny. Let me see if I can increase the font size a bit. Hopefully you can read this. Okay, so you get to a page that says Ubuntu Releases. You scroll down and you find the folder that belongs to the latest version, 18.04.1. And then it says, well, select the disk image, etc. But it lists all the files that belong to that image. And you can see up here, there's a file called MD5sums. And here, there's a file called SHA1sums. And here's a file called SHA256sums. And if you open that file, you get the MD5s, the SHAs, and the SHA256s, i.e. the hashes of the disk images. So this is the MD5 of this file, this ISO image, the desktop image, and this is the SHA of that other file, the AMD64 live server ISO. These are big files. If you download them, it would probably take you hours. Or depends on your internet connection. But what you could do if you download them, hypothetically, was to check the SHAs against the official MD5sums, SHA1sums, SHA256sums to see if it's the same image. You could then check consistency. You could check that someone hadn't swapped the image you downloaded for a malicious image that contained viruses and other code you don't want to run. Make sense? Yes or no? Okay. Well, we only have a few more minutes, so I guess we'll have to be quick here. The second one was one where I asked you to download a tar file, which is like a zip file on Linux, from this URL, and it contains a lot of copies of Crime and Punishment where I've swapped letters and I've made some changes to the files, and I wanted you to find out which were identical and which were not. So let us download the file. And actually, since I can't copy paste between Ubuntu and my host operating system, I think I'll have to bring up my own terminal. Not that one. Let me see if I can change it to this one. There we go. Now we have a terminal. Okay, I'm first going to download the file. And I'm not sure if you remember from the Linux course, but I told you about the application wget, which can download files if you type up the URL correctly. There, and file not found. Oh, interesting. And that's right. Was there a reason for that? Files. Okay, does anyone have the correct URL? Because I remember actually providing a different URL for that. I typed up the wrong one in the problem set. Can any of you please send me the correct one? If you still have it. Otherwise, I'll have to try and look it up myself real quickly. There we go. What was the difference there? Git slides, files, crime and punishment.tar.gz. Umuzi, GitLab, IO. Okay, I hope you've been given the right URL. But once you have, you can use wget to actually download it. Wget URL, it downloads the file locally and it'll be saved. Let me do ls, and here it is, crimeandpunishment.tar.gz. Now I think I'll just put this into another directory because I don't want to be in my home folder where I keep all my other files. Let me just call it crime. Created a directory called crime. I'll just move the file into that directory, crime and punishment. Okay, enter the directory. Okay, I hope I didn't confuse you now. I just moved the file into a directory where it's the only file right now. We're going to untar the file, which is just running the command that I typed up in the document. I know using tar can be a pain sometimes because you have to remember the flags to give it. But here you go. I untarred the file. It created a new directory called crime and punishment. And inside that directory, there are 10 files. Okay, and now the quick solution to this problem is find a hash algorithm, a hash program that you want to use. Let's use SHA-1 sum and run it on all the files in this directory. And if you remember the Git course, there is a shortcut to listing all the files in the directory, which is the glob or the star. So if you type SHA-1 sum star or SHA-1 sum asterisk, that expands to SHA-1 sum space first file name space second file name, etc. So if we run this command now, it actually runs SHA-1 sum on all the files in this directory. And again, the syntax is hash and file name. So if you look and have a look here, we can see that 1.txt has the same hash as 2.txt. So those files are identical. 3.txt seems to have the same hash as 10 and 8. So those files are identical. 4 seems to have the same hash as 9. So those are identical. Let's see now. 5 is unique. 6 is the same as 7. And I think we've identified which are equal. Of course, if you actually open the files, you'll see that all of them look very, very similar, because the only difference is there's a single letter here or there that I've changed. It's actually a full copy of Crime and Punishment, all 20,000 lines of it. So, okay, did that make sense? I'm sorry we've ran 5 minutes over time. But this is how I would solve that problem. Okay. So now we spent quite a lot of time going through hashes again. I hope they make some more sense today than they did on Friday. We've looked at how you can compute hashes from the Linux terminal if you need to. Later on in this course, we'll see exactly what hashes are used for in Git. They are very, very useful, and they make things easier in the Git world once you get used to the way they're used there. So I think that's it for now. That's all we had time for today. There are a few more exercises on that problem set, and I would like for you to try and do them. Except problem number 4 is definitely challenging. It's very challenging. I don't expect you to produce a perfect answer on that one. Just think a little bit about it. Try and think why a DAG might have the property that you can sort it, just for the sake of at least mentally trying to reason about DAGs. Of course, it takes time. It's not an easy problem to do. But if you actually get to an understanding of why that's true, that's very satisfying once you've seen the trick. I don't expect you to do that exercise. I don't expect you to finish that one. But do have a go at it. At least read it. Now, I think that's it for today. That's all we have time for. Next class, we're going to look at Git internally. We're going to look at how Git stores files. And all these concepts will show up again. We're going to see hashes, we're going to see DAGs, and we're going to see how things fit together. So thank you very much. Thank you for following the class today. Please give any feedback about the class to your instructors. You know, it's very difficult for me to actually gauge the class since I'm here quite far removed physically from where you are, and I'm talking to a camera. The chat helps, but it's not the same as being in the same room as you. So if I'm going too fast, if you think certain things could be reiterated or reviewed, please do tell me, and I'll take all of that into account. So thank you very much. And I'll see you again, I think, on Wednesday. So until then.